Hello, everyone, and welcome to Generate's Spring 2020 virtual showcase. We are, of course, doing our virtual showcase as of Social Distancing 2020. For those of you who are new to Generate, Generate is Northeastern's student-led product development studio. We are a program of the Sherman Center for Engineering Entrepreneurship Education. Before we get started here, I want to give a big thanks to the Sherman Center and our faculty advisors, the director of the Sherman Center, Andrew Goldstone, assistant director, Ted Johnson, and Professor Mark Savak. I am joined here today by our hardware director, Sarah Fairweather, and our software director, Anthony Wiriyaman. Say hello, or you guys. Generate is at another really great year in the Sherman Center. This was the first year of the Sherman Center's new makerspace, and it really feels like home for Generate and all the other programs. So it's been a very fun time, and you'll get to see some of the footage in our presentations today of teams working in that space, which is really cool. So without further ado, I think I'm going to hand it off to Anthony to talk a bit about the software teams, and then we'll get right into the videos they prepared.
Hi, I'm Anthony. I am the software director for this year. This semester we had two good projects, Butter and Mentor Match. What was new this semester was we sort of reorganized the teams to more reflect industries. So we added technical leads and more designers. That way people could have experience of development like it is in industry. So the projects this semester were a lot more well-designed, both from a visual perspective as well as a technical perspective. Our first video is going to be Butter. Butter is an app that provides hyper-local reviews of places. You'll be getting reviews not of the best and worst experiences, but rather what the local everyday visitor experiences. The video will discuss what the members of the team worked on and the journey along the way. Butter was led by Cullen Lampasso, who is actually a mechanical engineer. So this is the first semester we've had a non-software person leading a software team. And it was a great experience for him, and he learned a lot along the way. Here's the video.
Okay, go for it.
My name is Cynthia.
I'm Elena.
Anas Hussein.
Kaya Delochi.
My name is Clement Liu.
And this is Butter.
I personally worked on these recommendation forms, as well as the profile, and then I worked on these little square visuals that you see, as well as a few doodles that will be done by the end of today. Actually, haven't finished them yet, but yeah. So this is basically all that we worked on, and it started from something like this, where we really didn't have much of an idea of what we were working with yet.
So once we got into user testing sessions, we immediately found out that the users were relying way too much on the search page for whichever task they were given. So we expected people to spend most of their time on the feed page, and we soon found out that the feed page wasn't really visually convincing enough. It wasn't really telling the user that, hey, if you scroll down the page, you will have more content. Initially on our feed page, we had a top filter part that was kind of used as a minor sort of sorting and search function. But then we soon realized that it was actually doing the same thing as the search page. So we just got rid of that so that the feed page had more identity, had a clear purpose. And once we had that, we went into another. We went back to some of the users and asked them questions, and immediately we saw the change. People were more likely to explore and stick with the feed page, and actually scroll down and look for things.
I focused more on the back end for this project. And so for Butter, I was focusing towards working on the API, developing that to match the specs needed for the client, as well as developing the database to store all the information for the recommendations and the users and the different restaurants. Originally, it was a very limited amount of data that we had for a recommendation. It would just be like the recommendations ID and then some of the basic ratings that we had. But as we progressed, we discussed the different specs and the different details that we wanted to keep track for a recommendation. And so as that developed, we added more complexity and relationships between the data in the backend. And so now we have the users and then the different restaurant types and the user roles in addition to all the recommendations that we originally had.
Okay, so this is Postman, some just like a software that we're using to test all of our API calls. So the front end would ask something like get all of the recommendations, and this is how they would sort of phrase that. They would send it to us, and then we would return some basic information about the information. So this is kind of an ID that we use in our database. The recommendation location, what the actual restaurant is, some of the descriptions about what the restaurant is. And then this is getting the whole recommendation. So like I said, we're not trying to give them, like terabytes of information when they don't need it.
My job is kind of to implement what designers come up with for what the app should actually look like and what the user experience should be, and then also integrate it with the back end. One of the features that the designers came up with was this kind of overlapped view where different elements appeared like they were overlapped with each other. And that is something that's kind of difficult to do in React because the way things are laid is later things are always put on top of the earlier things. And so I actually had to reverse the way that it appears in the code.
I guess for me, this was my first time really doing some hands-on back-end experience. I think that was really interesting and meaningful for me through this project to be able to apply those skills and concepts that I've had from coursework.
What do you guys think?
I love the sound effect in the transition.
Cha-ching!
Cha-ching! Well, I would say that that was a very money presentation. Butter definitely looks a lot better than any of the software projects that we've had like in the past. I think the design has just gone up over time, which is super cool to see. And I think
Yeah, the design was awesome.
And it's cool to see like all the iterations of the design and the software, and it's like you can really see like the product development cycle at work.
Yeah, the overlay
I
effect.
think it looked really good.
It was really good.
The next project is Mentor Match, led by Nick Teffian, the project lead. Mentor Match is a platform that allows high schoolers to connect with alumni, to build their network and explore their different interests. The video will demo their website and discuss the different challenges they overcame throughout the semester.
Now that you understand our product, here is the front-end implementation based on the beautiful hi-fis our designers built. While you watch our demo, we're going to discuss some of the challenges we overcame through multiple iterations of the product development cycle. We realized during the development process that our authentication service, which grants users access to data on our site, was not sufficient. In our first iteration, requests were validated based on a user's role, admin, counselor, mentor, or mentee. While analyzing feature requirements, we decided this needed to be more complex. Our final version of the authentication service validates requests not only by user's role, but also based on the user's school and whether the information they're trying to access is within their scope. This second wave of validation based on user's scope fulfilled a core feature request from the client and simplified our end user's experience with consistent error messages. Another challenge we resolved through iterated design originated from our automated tests. At first, database logic was built into our GraphQL resolvers directly. This made tests difficult to write and errors frustrating to debug, conflating database issues with GraphQL schema or authentication issues. Investigating common problems in our failing tests revealed that we should separate database logic from our GraphQL resolvers, allowing us to test these pieces independently. Using this new design, we wrote unit tests for fetching data and integration tests for our GraphQL API, incorporating them into our build pipeline to ensure everything worked whenever changes were made.
What is the budget for these videos? That was so cool.
I didn't realize that Joe Exotic was using Mentor Match.
That was wild.
Hey, all you cool cats and kittens.
For Mentor Match, I think it was cool that they were using GraphQL because that's pretty neat technology to learn. It's like really hip and trendy these days.
Oh, the other cool thing about Butter was that it was a Scout project last 2 semesters ago. So it's cool to sort of see a project move around in Mosaic and sort of us working on existing designs and iterating on them and sort of implementing them.
Definitely. And Mentor Match was in Husky Startup Challenge last semester. All right, now switching over from the software projects, Sarah is going to introduce all of the hardware projects for this semester, of which there were 4.
Hi, everyone. I'm Sarah. I was the hardware director this semester. Like Reza said, we did have 4 great hardware projects. Partway through the semester, campus closed down, so all of the teams took it upon themselves to work from home and do their best as they could. Some teams actually prototyped at their own houses, and some teams did their best while working on CAD and other electronic documents. So the first project we have up is Deep Charge, led by Jacob Wanda, and this is a wireless charging UAV landing pad.
Hi everyone, my name is Jacob Blonda and I am the project lead for Deep Charge. So the client Deep Charge is a startup based out of a Northeastern research lab focused on wireless networks. Now, they are currently in the process of creating a UAV or drone wireless charging pad called the FlyPad. The FlyPad is a portable landing pad that can wirelessly and automatically charge the UAV without a need for positional accuracy during landing. Upon first meeting with the client, they had a breadboard and PCB proof of concept, as well as an industrial design CAD model for the overall look and feel of the design. Now, Deep Charge requested help from Generate to further develop the FlyPad into a cohesive system. For the internal electronics, Generate was tasked with designing the power distribution system. For the mechanical side, Generate was tasked with continuing and improving the current design, which includes the structure and placement of all internal components while using the industrial design concept as a guide. Because of the current situation, we changed our plan to mostly focus on the design side of things, and Anuj, Charlene, and Michael are going to talk more about that.
Hello, I'm Charlene.
And I'm Michael.
And we are the mechanical team for Deep Charge. Our first step was to outline our goals for the overall user experience of this FlyPad. Some considerations we had were ensuring that pad is portable and mechanically sound and can house the components in a sleek and minimalist form factor. We also had to make sure that the FlyPad's weight was evenly balanced and that it could withstand the wear and tear of different environments.
In order to further define the user experience of this product, we created a simple plywood prototype. This allowed us to gain a better understanding of the size, shape, and weight that we were working with. From here, we planned on making a more refined version of the prototype, and this would be a works-like prototype that would accommodate the various internal components and provide a platform for our client to test their technology. However, we had to shift gears and work on tasks that could be done remotely. So we decided to focus on a more fleshed out and manufacturable design that would be created in CAD software.
One design choice we made was to have the enclosure be injection moldable. We felt this would be most economical for manufacturing this product in bulk and would allow us to consolidate multiple features in one part for ease of assembly. While this allows us for a lightweight enclosure, one challenge we faced was ensuring that it was stiff enough to support the internal components and withstand multiple cycles of folding and unfolding. Another challenge was minimizing the stress experienced by the enclosure at the hinge points. To do this, we added a metal feature to attach the hinges to the plastic enclosure.
While the folding feature of the pad improves portability, it creates a new problem of having to transfer wires across the two halves. Our solution was to create a non-load-bearing hinge through which the wires could be threaded. This idea came after looking into how laptops fold despite having wires running between the screen and the keyboard. The arrangement of the internal components can be seen here. We had to accommodate our mechanical features, the client's coil modules, and our power distribution components. These include the batteries, a battery control board, and isolated DC-DC boards.
Hello, I'm Anuj. I was part of the electrical team for Deep Charge along with Elliot and Anthony. Our main task was to design the power distribution system for the wireless charging technology developed by the client. For the system, our client wanted to have the power distribution interface with the microcontroller and to be battery powered in order for the pad to be portable. And so one of the main elements of the battery management is to introduce circuitry that can balance the power levels of each individual cell. We want to do that so that we can get a constant and reliable amount of power. Another element of this battery management system is a charging system for recharging the batteries within. This charging system and power balancing utilize integrated circuits, or in other words, mini circuits. These mini circuits take care of what is involved in the power balancing and charging systems and removes a lot of design hurdles, as you don't have to custom design our own subsystems. With the power management system, the main goal of the system is to convert the power supplied from the batteries to power levels usable by the wireless charging system. The challenge with this power conversion is that the power conversion has to produce power levels that are isolated from each other. The client wanted this in order to prevent these power levels from disrupting each other. Throughout the power management system, and for each power level, there are voltage and current limiting circuits. These allow us to regulate power consumption at each point of the power distribution system. Unfortunately, when we had to shift gears from remote work, we could not implement a microcontroller to interface with the power distribution system, and this prevented us from implementing any user feedback about the power distribution system. However, by creating hardware access points, we were able to design the power distribution system that can work with or without a microcontroller. Nonetheless, after verifying our electrical designs through simulation, we were able to implement a power distribution system that meets most of our electrical deliverables for the client. Without this power distribution system, the wireless charging system cannot be a product. And while we can have new and innovative technologies available, these technologies cannot actually be viable products if there isn't anything to distribute power to it. A significant part of product development isn't just building technology itself, but the base behind that technology. And that's where the Deep Charge came in. We designed the mechanical enclosure and power distribution system, providing the client the right base for building a valuable product from the wireless charging technology.
Awesome. What do you guys think?
I'm going to need another 6-year degree to understand that. It was really cool though. Like, the one thing I really like about this project is that they're taking some product produced in a lab but isn't user friendly yet and productizing it and making it so that they could actually bring it to market, which is, I think, a really cool application what they're doing. And there's a lot of interesting technical challenges that they had along the way.
I think Anuj really summed it up at the end, saying like product development is about bringing technology to users, and I think that really encapsulates what Generate is trying to do.
And especially with the whole pandemic going on, they had to kind of shift gears with what they were doing. So moving on towards like making the CAD manufacturable and looking into injection molding and stuff, I think that'll really help out the client.
All right. let's go to the next one. Who's next?
Next up, we have Good Sticks, led by Sarah Liebler, and this is a dispenser for environmentally conscious eating utensils.
Hi everyone, my name is Sarah Liebler, and I'm the project lead for Good Sticks. Our team, Izzy, Ben, Jack, me, Liza, and Morgan, designed a dispenser for edible biodegradable chopsticks and created 2 iterations of the full dispenser prototype. The main goal of the dispenser is to reliably dispense a pair of Good Sticks easily while preserving the freshness of the stored Good Sticks.
We started out our design process by going down 2 separate routes. The first was to explore a rotating mechanism, and the second was to explore a lateral bar linkage. The 2 groups prototyped, brainstormed, and iterated on those designs to find out what the pros and cons were. For the rotating mechanism, we realized there was an increased part count and part complexity, in addition to increased number of failure modes. The lateral bar linkage proved to be simple, elegant, and easy to maintain. So what you'll find in our final prototype is the lateral bar linkage.
After making our first iteration, we wanted to incorporate a user testing aspect. So during all hands, people came up to our table and began to use our mechanism. We asked them to scan a QR code that led them to a survey that asked them questions about what they liked and didn't like about our mechanism. And from there, we went on to make our second iteration.
After user testing our first prototype, we took a look at how we could improve each part of the dispenser. For the mechanism, we kept the basic idea of pushing a button to push the chopsticks out the same, but we streamlined the design to replace 6 parts with 1 sweeping lever. We flipped the mechanism so that it was more right-hand friendly, added a way for the button to seal, and made the spring attach to the back of the housing and extend from there. For the filling channel, we finalized the angle of the tapered walls, shortened the vertical channel, and made a separating wall for the 2 chopsticks within the channel. Finally, we added robust ways for the channel and mechanism to attach to each other and to the housing, and made sure that they would all work in harmony.
The housing of our final prototype is made of 6 panels of laser-cut acrylic attached internally by stainless steel corner brackets. The outer housing is sealed by a food-safe silicone extruded between each panel. The chopstick exit slot is sealed by 2 pieces of a modified compliant D-shaped rubber. As the chopsticks exit the dispenser, they push through the seam between these 2 pieces of rubber. Instead of loading the chopsticks from the top like in our initial prototype, our final model has a door on its right side which acts as a chute for the chopsticks to roll into the feeding mechanism. Our final model also has a door on its left side for maintenance in case of jamming or malfunction. These doors are sealed by a food-safe rubber and are attached to the outer housing with hinges and thumb screws.
The next step for our dispenser is to perform design for manufacturing to reduce part count and to make it possible to mass produce. In the short term, we may create multiple prototypes of this design to be used in Good Sticks product trials and demos.
Outside of the engineering focus of this project, there is a parallel track of user interface and product branding development. We created some initial branding for our first prototype, including a set of colors, typefaces, and logos. This was demonstrated at our all hands presentation. After feedback from users and some branding material from our client, we pivoted to a new color scheme, logo design, and dispenser front panel graphic. Both versions of the branding feature visual cues to assist the user in operating the product. This new branding can be seen on both our final dispenser and throughout this video.
Because of the coronavirus shutdown, our work became remote shortly after all hands. Our team continued to Zoom together and CAD together, and we were able to outsource all materials for our final prototype. Although we lost some time, everyone's hard work made it possible to achieve our priority deliverables. This project was a ton of fun to work on, and I'm happy to have had the opportunity to work with such an intelligent, hardworking, and enthusiastic team. Thank you to everyone who contributed to making the Good Sticks dispenser a success.
So wholesome.
So wholesome. What a wholesome squad.
I'm still disappointed that I wasn't able to try those Good Sticks.
Oh, to try to eat them? Yeah, I didn't get a chance either. I was the first person to user test at all hands. They did not take my suggestions.
What were your suggestions?
They were bad design, apparently. but it's
It's a good
okay.
thing they didn't
This
choose
is
me.
this is why I'm not on that project.
Any
Right.
thoughts, Anthony?
I mean, I think they're one of the like more wholesome teams, and I think that they spend a lot of time together during the semester. I think it really shows. Like once they move offline, you could still tell that they were working hard together and they were like really engaged as a team. It's really nice to see how teamwork is like really important to the project as well.
Yeah, and I thought it was also great that they were able to outsource their materials and have Ben work on the final prototype and actually get that built instead of just, doing CAD for the entire last month.
Totally. All right. Let's see. Is this last but not
Last
least?
one. Yep, last but not least, we have Med6, led by James Ridson, and this was a wound drainage medical device that automates post-operative wound monitoring.
Hi, how's it going? I'm James Ridson. I'm the project lead this semester for the Generate project Med6, and I'm very excited to show the hard work that my team has put into this project. So the problem that Med6 gave us was that post-surgery patients are having difficulty tracking the color and volume of their wound discharge after they leave the hospital. And this leads to patients being readmitted to the hospital and increased mortality rates. In addition to the problem, they also gave us a scope that they want us to work on throughout the semester. Med6 would like Generate to create a functional prototype, develop a volumetric measurement mechanism, and conduct user experience research and development. So the first stage of this project was to do research. We had three main goals for our research. The first was to understand the current solutions and experiences that those solutions create. So we did this by interviewing doctors, patients, and nurses to understand their experiences with the current solutions that are on the market. And then we also created user experience maps from those interviews. The next goal of our research was to digest that information that we got from the interviews. So we did this by creating mind maps and affinity diagrams. We implemented this research by creating product requirement documents and then also using those requirements to brainstorm different solutions to the problem. So this is an example of one of the user experience maps that we made. I chose this one because this is like a full timeline of the entire experience that someone has. So we identified a lot of different problems that people are having with the drains throughout this process, and then we addressed those in some of the features and the designs that we created later in development. So the solution that we came up with was a smart wound drainage system that tracks volumetric and color data in real time. So we broke this solution into 5 main subsystems, the first of which is volume sensing, the second is suction, third is body attachment, user interface, and the control system. So this is an example of some of the concepts that we came up with for the different subsystems. There's some body attachment, there's some industrial design on there, there's different mechanisms, there's electrical architectures. So we're really thinking about a lot of different things simultaneously. We're taking a very multidisciplinary approach to the brainstorming and to the development of this product. But the most important thing we wanted to nail down during brainstorming was the mechanical concept, because this really drives a lot of the other subsystems. So we decided upon this idea that works a lot like a syringe, but instead of the plunger of the syringe being driven by your hand, it's basically driven by a motor. So with this concept chosen, we went into the development phase. First thing we wanted to do was validate this mechanism that we had decided upon. This was a little bit before big coronavirus and all that craziness. We were still on campus and we were actually able to validate this using just an off-the-shelf syringe, as you see here. In addition, we also did some mathematical modeling to make sure that a motor of the size that could be able to fit in this would be suitable to create the amount of suction that we needed, and we validated that. We also made some CAD development for a worksite prototype of this, so you can see that here. So after we validated that that mechanism would be possible, we did some industrial design development as well. Again, going back to that multidisciplinary approach to development. This is one of the designs that we came up with. This is another one, kind of a more, I guess, like flask-shaped design. And then we also did some work on electrical development. So we had three main leading concepts for how we wanted the system architecture to work. This is basically a circuit diagram of that third idea that you saw. In addition to electrical development, we also did some UI development. So this is kind of a little bit more fleshed out idea of the pager, what that would look like, what different screens and information would be shown on there. And then we also, since we can't physically prototype these things, we wanted to understand, how this would look on somebody with a drain as well, and with this attachment mechanism. So yeah, we created this body model to understand, how it would look. We also fleshed out in pretty good detail the application experience, the mobile application experience. These are some of the screens that we created for this, just to understand, what would that look like, what would that feel like if this information was shown on a phone. Next steps, just to reiterate the scope that I went through at the beginning. The Generate worked on was just the user experience research, the mechanism design, the functional prototype design, and then the user experience development. Med6 can use all that to, they can take our development and move it forward. They can iterate what we've done, and they can validate a lot of the research that we've done, both in terms of, prototyping, but also our assumptions about what features people would want, and they can do that by creating user tests. Thank you.
Woohoo!
I think it's super cool that they're an example of a team that's sort of like in a different part of the product development cycle. The product development cycle is like so big, and it's nice to see products in different stages. Obviously, they're in like a much earlier stage in some of the other projects we saw this semester, but it's cool to see like sort of the different steps and what you need to work on in different stages of the product.
Yeah, I thought it was really interesting that they did a lot with the user experience. So how the app was going to look and kind of getting those storylines. That's something that I don't think most Generate projects go into. So I think that was a really cool experience for them.
Yeah, definitely really cool to see them working a lot in ideation and really fleshing that out. All right, well, it seems that that's all of the projects that we have for this semester, a whopping 6 projects. It's really awesome to see. We've had 6 projects both semesters this year. And that's it for our management team this year. All 3 of us will be no longer, well, you 2 are graduating, fortunate for you. I will have 1 more year, but all 3 of us will no longer be on the management team. It's been a really awesome experience to get to lead this organization and see all of the progress that everybody's made. It's crazy how much the community stayed together, even once we all had to go into self-quarantining, and just to see like the progress still got made and people are still excited to meet with their teams. Everything is really amazing. So Generate community, Sherman Center community is really strong right now. And it's been a great time. I think the next thing I'm going to do is introduce the leadership for next year. The executive director for the 2020-2021 year will be, do we get a drum roll here? I think we can like cut in a drum roll and we'll go for like 5 minutes and then I'll say, Nick Caffeine. Nick was the project lead for Mentor Match, as well as a co-director of Husky Startup Challenge this semester. He's also started and ran his own company for a while, Boston Ocean Apparel, look him up. And it's really great to have him be leading this organization, being a leader in the Sherman Center next year. So thank you all, stay safe, and adios.